Hi everyone, welcome to video lecture of network management subject. In this video lecture, I am going to give a brief explanation of module 5, that is network management application, which is the last module of network management subject as per the video syllabus. Well, as you all studied about introduction of network management system, how telecommunication and data communication work in module 1 and module 2 previously. Okay, no problem. I would like to overview of network management again. Now let us understand the term called NM. It stands for network management. It is the process of administrating, managing computer network. That is, it provides services such as fault analysis, performance management, provision of network, maintaining quality of services. Let us understand what is NMS. Stands for Network Management System. It is a set of application software used to manage network. That is, it is a network management system or software designed for monitoring, maintaining and optimizing network. It includes both hardware component and software. It provides multiple services such as network monitoring, device detection, performance analysis, device management, fault management. Now let us start understanding of network applications. As we know that network management system involve management of network and system resources. As OSI defines network management as a 5-layer architecture, also called as 5 levels. The figure shows network and system management. Here it consists of 7 components, that is business management, service management, network management, system management, element management, resource management, and network element and system resources. These all the components are arranged in a level. Start the level, high level, level 5, level 4, level 3, level 2, level 1. The lowest level is level 1. The highest level is level 5. Level 5 consider business management, level 4 consider the service management, level 3 consider as a network management as well as system management. In the level 2, it contains the element management, resource management. In level 1, that is the ground level, where it consists of the combination of two components, that is network elements and system resources. Now let us try to understand the working. The level 5, that is called highest level, where the business management deals with the managing a business, called as business management. It applies to all the institutions such as commercial business, educational institute, telecommunication service provider, or any other organization that uses a network system to manage their business. Looking into the service management, where it manages the service that provided by the business management. Coming to the level 3, the network management. It manages the network and software components. Looking into the system management, it manages the systems. Looking into the level 2, where it consists of element management, it manages the network elements like hub, switches, router, gateway. The resource management manages the resources such as processor time, memory, I/O, and database. The finally, the network in the ground level, level 1, consists of network element and system resources, and both are combined. It is called as the network information system. So this is all about the working of network and system management. Now let us know a different category of network applications. It has 8 applications. The first one is the configuration management, secondly the fault management, third one performance management, fourth one is event correlation technique, fifth security management, sixth account management, seventh one is the report management, and the finally eighth one is policy based management. Now you will learn in detail all these one by one. Looking into the first one is configuration management. It is the management of configuration of network element and computer connected. Used in the context of discovering network topology, mapping of network, setting up the configuration parameter. The network configuration management supports 3 important components: network provisioning, inventory management, network topology. Let us know in detail about these one by one. Network provision. Provision of a customer service to the new elements. That means the process of providing user with access data and technology resources. It includes setting up a network to be accessed by user and servers. For example, in telecommunication, provisioning involves the process of preparing and equipping a network to allow it to provide new services to its users. Thus, the thus the customized for customer specification. Looking to the second one is inventory management. Inventory management system is the combination of technology, hardware, software, and database. It is the process and the procedure that oversees the monitoring and maintenance of network and system components. Therefore, the network inventory management is the process of keeping a record of all the IT or the network assets that that makes up the network, and it enables the network administrator to have a physical record of all IT and network equipment within organization. Looking into the third one is network topology. Network topology is the arrangement of element of communication network. It can be used to define or describe the arrangement of various type of telecommunication network. Therefore, network management is based on the knowledge of network topology. As network grows, shrink or otherwise changes, the network topology need to be uploaded automatically. Let us consider an example. ARP command. ARP stands for Address Resolution Protocol, as you studied in the computer network. So ARP command can be discover any network component that respond with an IP address, which can then be mapped by NMS. Auto discovery can be done using a broadcast ping on each segment. We need to discuss the 4 important topology configurations. The first one is LAN physical configuration. Second one is logical configuration of 2 LAN segments. Third one is virtual LAN physical configuration. It is called VLAN physical configuration. Fourth one is logical configuration of 2 virtual LAN segment. Let us know in detail the first one, LAN physical configuration. Looking into the figure, it consists of a router, then port A, segment A, the port B, segment B, and the port A consists of hub 1. In the hub 1, in turn, it contains the A1, A2 systems. In the hub 2, it contains B1, B2 computer. The above figure shows the physical configurations of conventional LAN. The router in the figure can be visualized as a part of a backbone. There are two LAN segments connected to the router, segment A and segment B. They are physically connected to two physical ports in router. They are identified as a port A, port B, corresponding to segment A and segment B respectively. Both LAN are Ethernet LANs and use hub configuration. Two hosts A1, A2 are connected to hub 1 on LAN segment A, and two hosts B1, B2 are connected to hub 2 on LAN segment B. Looking to the second one, that is logical configurations of two LAN segment. The figure shows here there is an two system A1, A2 tunnel. Again, the router is in middle, and the B1, B2 systems are connected on both tunnel. The figure shows the logical configurations of figure A, what we discussed in the previous. The logical configuration, what the auto discovery process detects, it is very similar to the physical configuration. Segment A corresponds to LAN on hub 1 with the host A1, A2. It is easy to conceptual visualize these and easy to configure. Looking into the third one is VLAN physical configuration, that is virtual LAN physical configuration. So figure shows here there is a router, and again the port A, port B, segment A, segment B, which is separated in the previous diagram. It has been combined, and there is a switch in between, and the switch again consists of segment A, segment B. Each segment consists of hub 1, and each hub 1 consists of two computer A1, B1, and the hub 2 consists of A2, B2. Looking to the figure shows a virtual LAN physical configuration, where the physical configuration of two virtual LAN, we notice that only one physical port A is used in the router, not two as in the case of the traditional LAN. The host A1, A2 are configured to be on the VLAN 1, and the host B1, B2 are configured to be on VLAN 2. Let us assume that it is done on port basis on the switch. Thus, the two ports marked segment A on switch are grouped as a VLAN 1. The other two ports marked segment B are grouped as a VLAN 2. Thus, segment A covers correspond to VLAN 1 and segment B correspond to VLAN 2. Therefore, we observe that VLAN 1 and VLAN 2 are spread across the two physical hubs, hub 1 and hub 2, with a layer 2 bridged network. So VLAN network is an efficient one. So looking to the fourth one is logical configuration of VLAN segment. The figure shows here. In the figure, a logical configuration of two VLAN segments. Here, logical view of physical VLAN configuration is presented. We see that host A1, A2 still belong to segment A, but are on different hubs. Likewise, host B1, B2 belong to the segment B. Therefore, auto discovery process would not detect the physical hub that are identified. Now, the second one is the fault management. We'll try to understand what is fault management in network management application. It is the process of managing any type of fault occur in network. It is normally associated with the failure of network components and subsequent loss of connectivity. The fault management involves a 5-step process. First one is fault detection, fault location, restoration of service, identification of a root cause of problem, finally the problem resolution. Let us study one by one. Fault detection. It is the detection of fault occur in a network. It detects which system or the network components fail to perform or not working. It uses a command ping periodically and wait for a response okay or not okay. Looking into the second one is fault location. It involves identifying where the problem is located. It helps to resolve fault occurs in that location. The origin of the problem would be traced by walking down topology tree where the problem starts. Let us see an example. Interface card on a router has a failed. All managed component connected to that interface would indicate that the failure. Looking to the third one is restoration of services. It restores the services performed when a fault occurs. It takes higher priority over diagnosing the problem and fixing it. Example, if an LAN network, one computer performing a task, then any network component failure, automatically that task information will be restored. And when component repair, it then consider that task, that is, it is try to avoid a loss of task information. Moving to the fourth one is identification of root cause of problem. Identification where the fault occurs and try to analyze the cause of problem occur. It is a complex process. Moving to the next one is the problem resolution. After resolving the fault occur, the trouble ticket can generated to resolve the problem. It report to user that service is started. Trouble ticket could be generated automatically by network management system. So this is all about the fault management system. Looking into the third application, that is called performance management. So this is very important as per the examination point of view. As you know that it going to manage the performance of network. It always available and should be high speed operation. It monitor traffic in network and do the management. It control loss of packet in network. It involves following. The first one is performance matrix, second one is data monitoring, third one is problem isolation, and fourth one is performance tuning. Let us try to understand in detail what is performance matrix. The parameter that can be attributed to define the network performance on a global level, like throughput, response time, network availability, network reliability. metrics on these dependent on what, when, where. The measurements are made in the real-time topic performance metrics are latency, that is delay, and the jitter, that is slightly irregular movement. Looking into the figure of a topic flow measurement network characterization, where it consists of the different levels. Start with the level 0 from the bottom, level 1, level 2, level 3. In total 4 levels are there. Each level is assigned labeled a name called international backbone. Next, level 2 regional or middle level. Third, level 1 it is a stub or enterprise. Level 0 assigned as a end system or host. The network is characterized as a topic passing through 4 respective levels as shown in the figure. Backbone networks are those that are typically connected to the other network and do not have individual host connected to it. The regional hosts are subscribed to a backbone network. The stub or the enterprise network connect host and LAN are subscribed to regional and backbone networks. The end system or the host are subscribed to all of the above. Therefore, the architecture defines the 3 entities for traffic. Therefore, the architecture defines the 3 entities for traffic flow measurement. First one is meters, meter reader, managers, where the meter observe the network traffic flow and build up a table of flow data record for them. Next one is meter reader collect traffic flow data from the meter. Manager oversees the operations of meter and the meter reader. Looking to the second important is data monitoring. Data monitoring in the network for abnormal performance behavior such as high collision rate in Ethernet LAN, excessive drop due to overload, etc. are detected by traps generated by gents and remote monitoring. The performance related issues are detected primarily using trap messages generated by remote monitoring probes. The thresholds are set for important SNMP parameter in the remote monitor, which is then generate alarm when the preset thresholds are crossed. Then the third one is the problem isolation. The isolation of problem occurs in network for performance related issues depends on the type of problem. A higher percentage of packet loss will cause a loss of connectivity, which could be intermittent in this situation. Monitoring the packet loss over an extended period will isolate the problem. Looking to the next very important term is performance statistics. The performance statistics are used in the tuning a network. It analyzes the different LAN connected services of packet and gives the statistical analysis. It gives what is average performance of the particular network. It collects the statistic of data locally with the degrading the overall performance of a network. Looking to the statistical data on the topic are collected and the periodical reports are generated to study use of tags and project needs. Thus, trend analysis is the helpful for future resource planning. Hope you understood the concept of performance management.